final video in this series, we're going to look at two situations in which we have elements that do not form ions at all. The first of which is the element carbon. So we're going to take a quick second in order to construct the Bohr-Rutherford diagram, and once again, at this point, all of this should be second nature. So again, we're just converting the atomic mass into the closest natural number and subtracting the atomic number from the atomic mass number in order to find that carbon has 6 neutrons, and since the atomic number is also 6, this means that carbon has 6 electrons, 2 in the first electron shell that exists as a pair, meaning that we now have 4 electrons to include in the second shell, which is also going to be carbon's valence shell. And after we put these 4 electrons in like this, we can see the reason why carbon doesn't actually form an ion at all, or rather why carbon ions are exceedingly rare. So if we take a look at the valence shell, which has 4 electrons, this means that carbon can both gain 4 electrons or it can lose 4 electrons. Now, if anybody asks which is easier, gaining 4 and losing 4, if that sounds like a trick question, that's because it is. And generally speaking, carbon can just as easily gain electrons as it can lose electrons, and this is why carbon doesn't actually form ions, because rather than gaining or losing the way that most metals and nonmetals typically do, carbon actually presents a fourth option, which is actually sharing 4 electrons with other elements. And this results in a type of interaction between carbon and other elements, which is what we call a covalent interaction rather than the formation of an ion. And this is why elements such as carbon that have a valence shell that is exactly half full do not actually form ions at all, because once again, they fill their valence shell through a third option, which is sharing valence electrons. And when we look at the existence of covalent compounds, we will see exactly how this happens. Now, the second example is actually even more straightforward to understand, so let's go ahead and construct the Bohr-Rutherford diagram for neon, starting with identifying the components of its nucleus. So again, we can round 20.18 to closer to 20 rather than to 21, and simply subtract the number of protons from the atomic mass to find out that neon has 10 neutrons, and because its atomic number is 10 as well, this means it has 10 electrons, the first 2 of which we put into the first shell as our first pair of electrons. And right now we should see that because there are 8 electrons remaining for the second shell, those with foresight can see the logical reason why neon doesn't form ions at all. So we add our first 4 electrons in, and then we put the second 4 in to give each of the 4 electrons a pair, and we have just used the 8 electrons that neon has. And again, what we see that because the second shell is neon's valence shell, we can see that neon already has 8 electrons. Now, because 8 electrons is a full octet, this means that neon doesn't need to gain any additional electrons because, again, it already has a full valence shell, and it also means that losing electrons has no purpose because, once again, its valence shell is already full. Now, those of you with foresight probably recognize that neon is an example of a noble gas, which are the family of elements found at the far right-hand side of the periodic table, and as with all noble gases, neon already has a full valence shell, and therefore it doesn't need to gain or lose electrons because it already has a full exterior shell. And for this reason, the noble gases are the second category of elements that really don't form ions at all, except again in some very unusual situations. This concludes our short review series on atomic structure and constructing Bohr-Rutherford and Lewis diagrams of atoms and of ions. Now, before you move on to the first formal series looking at the formation of ionic compounds, make sure that your foundation of ion formation is solid by trying the 8 practice problems below. In these problems, you'll need to construct the Bohr-Rutherford and Lewis diagrams of each of the 8 elements, and then identify whether they will gain electrons or lose electrons to form an ion, or, in the case of certain elements, whether they don't form ions at all, and why this is the case.